It's really a great pleasure and a great honor to be here. Actually, it's my first time here at any of the Linux events. Although I must tell you, I've used many of the products that these teams and teams like yours help create, and there's an increasing number of them that I'm using every day. And at Qualcomm, we see this as a huge business opportunity. So I thought when the team asked me, would you like to come and say a few words about it, I was delighted. And once again, thank you so much for having me here. What I thought I'll do in the next 20 minutes is really talk to you a little bit more about the business of smart devices and Internet of Things. I used to be a technologist. I can't really claim I am one anymore that much. So I'm probably going to give you a little bit of a perspective on how we see things in terms of business and in terms of opportunities for people in this audience and for all of us who work in these topics. So I have a few slides here which I'll use more as pointers for me to make the comments I wanted to make in the time I'm given than anything else. Firstly, I've been in this business 25 years, and it's very interesting for me to see, the slide the previous gentleman was presenting about embedded versus IoT, and what is that? OIC, all seen, all join, OCF. Hopefully, I'll give you a little bit of color and perspective on those things. Firstly, I guess if you look at a timescale perspective, embedded computing and things that are embedded have been here before IoT, just because the word IoT is a little bit more recent than anything else. Maybe most of you are tired by that word already. Hopefully, I'll try to give you a little color of how we think of IoT and what that really means. But if you look at here, we have a whole bunch of products that we use in our homes, in our daily lives, in the infrastructure that use embedded Linux, and does a really nice job. Now, I wanted to talk about IoT. Now, the IoT, basically, the part of it that's different, and maybe the part of it that's, I would say, new to the embedded part is really the I part. You can think about the I part as connectivity. The real difference is that more and more devices are getting connected. And while it seems like a very simple, innocuous difference, it wasn't connected, it's connected now, still it does the same thing. Well, actually, it changes dramatically what they do when they're connected versus what they do when they're not. And that is really the heart of the matter. The heart of the matter for embedded Linux moving forward is to embrace the aspect that all these things are now going to be connected. And when they're connected, it's a different beast altogether. And I'll talk a little bit about that. If you look at telephony, 2002, once these things become mobile, you can already see telephony was totally redefined when mobile changed the fixed voice to mobile. Completely different animal now, what's a phone having in your house to somewhere else. The simple concept, I've been in the industry for a long time in mobile, is that when someone mentioned to me once that, hey, everyone's going to have their own number. I mean, it seems strange now, but numbers were associated with offices and homes, not people. But now a phone number is a personal device, personal number, not a house number. So that's a huge difference. And computing, I mean, most of us thought of computing as things that computers that sit at your desk and desktops. But it's no longer true. In most places, the first computer many people would use is actually their smartphone. And I think more people will get onto the internet now on their smartphones than they ever did on their computers. They don't really think of internet as something that connects to a PC. Internet is something that they do it on their phone. Even more so as we start bringing in, like in the next few years, we'll bring on another 3 billion people in the rest of the world that will be on the internet, and their first experience with the internet will probably be on their phone. Now, here comes probably the impactful part of our IoT is that now we are not talking about changing the phone or changing the computer. We're talking about connecting everything else that's around you. So if you think about the magnitude of the impact you've had when phones went mobile and connectivity went from desktop to mobile phones, you see the impact that will have when everything you have around you is connected. It's actually that radical a change. And no IoT talk goes without some number of some kind. And usually these are some large numbers with a B next to it. And you pick. I picked 25 here. But actually, the interesting part I want to make is so many people ask me when I do this kind of talks that what makes you believe it's going to be that big? I'd like to give a couple of examples to maybe drive the point home. If you ask this question to an audience like this, it's probably not a very fair audience, but in general, I give talks like this at many different audiences. If you ask the question, how many IP addresses do you guys have at your house? It's kind of a really strange question to ask at a party or something, but I do that sometimes just to see what happens. And I get varying kind of answers. I mean, you probably started thinking about it. Usually, most people thought 1, if they're connected, they have like an access point. I counted 43 the other day in my house. Actually, it's not that hard. If you buy a TV now, it comes connected. If you buy a connected speaker, it comes connected. If you buy a Bluetooth speaker, it's connected. The thermostats are connected. Now we got light bulbs. My solar system came in connected. I just upgraded my security system. Actually, I didn't make a conscious decision to upgrade. My contract ran out. The new guy from ADT came in, and everything he put in is connected. Maybe 20, 30 connected things, from doorknobs to whatnot. So before you know it, you've got a gazillion IP addresses in your house. So it's not really hard to think of that number. We ship about 1 billion mobile phones. So shipping 25 billion devices that are connected is not that hard. Now, there comes the opportunity for people in this community, because now, if you think of embedded Linux, think about connected embedded Linux, and there is IoT. And it is actually that simple. It's really not a very complicated argument. I'm not one for terminologies, but I think the opportunity and the challenge for the Linux community is to figure out the fact that every device you develop software and now is going to be connected to the internet in some way. And what does that do? Actually, what that does is actually quite a bit different. And I'm going to try and motivate that. Actually, here at the bottom, we try to do this at Qualcomm, where we try to bucketize, for lack of a better word, everything that you buy into stuff you wear on your body, stuff you put at home, and stuff that lives in the cities. It's as arbitrary as any other collections. But we try to put it that way just so we can kind of categorize them by the characteristics of those devices and what that means to things that we make in them. So I'm going to dig a little deeper into each of those areas and talk about what that means and the unique challenges they pose. So if you think about things you wear on your body, you can think about them as watches, you can think about them as headsets, you can think about them as smart glasses, well, VR headsets, things of that nature, smart clothing. There's an interesting thing you observe. The first thing you observe is that what this word or this phrase a lot of people use called computing at the edge. It's another terminology that kind of sounds weird. But let me try to motivate that. When fitness bands first came out and everybody wore a fitness band, typically, we found people wear them for about, 6 weeks before they figure out what it does. And the interesting thing is, when they first wear them, and if you're like me, you wore one of those things, you went to the gym, and you want some instant feedback on, okay, how many calories did I burn? And well, guess what? It doesn't show you anything. It's got a blue light and a pink light or something of that sort. So then you have to pull out your smartphone, which you left somewhere else because you're on the gym. Very quickly, you realize this is not going to do it, and then you decide to put a display on the device. Well, they call them watches now, smart watches, but that's beside the point. The point is that now you needed some kind of feedback, so you popped a display on that. Actually, very interesting things happen when you put displays on devices. What happens is people expect them to behave like their smartphones. That's because we've set the expectation and set the bar on what display should be like. I mean, you probably see so many people, if you guys have little kids, touching screens, and the screens don't respond to touch. They're like, how can a screen not respond to touch? Because we've not set the expectation that all screens are touch-enabled. So here you go. You have watches now that need to respond to touch. Next thing you know, you try to do that kind of number, and if the frame rate is not 60 frames per second, you think it's slow, and it's cheap. So we found that a whole bunch of people are buying Snapdragon mid-tier processors to put in their smartwatches. And guess what software they run? They run Linux. And there is the opportunity that as things get connected, suddenly you drag in application processing along with connectivity because the expectation of what smart devices have to do when they're connected is set by the smartphone. And once you add connectivity and application processing, you need the same experience that has been in smartphones, and therein lies what people kind of call computing at the edge, because now you need processing at the end terminal. And we are finding that now on headsets, we're finding that now on watches, we're finding that in clothing, and many, many different opportunities. Now we find that we need to put application processing along with connectivity. There's another interesting aspect to it, which is when you make things connected and they have processing, they can do a lot more than they could before they were connected. So what do I mean by that? So a lot of you remember getting MP3 players, and you walk around with an MP3 player. You got to remember to load the music in it, otherwise you're in the gym and it plays the same song, you're tired, and you don't like it. Now when they're connected, I never remember to load music on my music device because it's connected, and I have Spotify, one of those subscriptions. Suddenly you never have to think about loading anything on it. So now you see that connected devices suddenly take a new persona, if you will. Think about digital cameras. I mean, the fact that you could take a picture and then you connect it to your phone and download the picture and send it up versus taking a picture of the smartphone and putting it up on Instagram right away. So now when they're connected, the applications that need to be done, the response time it needs to have, the performance it needs to have, the kind of things they need to do are very, very related to what your smartphones do. And that's really the opportunity for embedded Linux in connected devices. Similarly, things at home. We talked about home and connectivity at home, and we talk about all the devices that you could buy, from thermostats to TVs to light bulbs and so on. There's a couple of comments I want to make, maybe a little bit controversial, a little bit provocative, but it's fine. We talked about OCF and OIC and all that kind of stuff. I tell you, from Qualcomm, for someone who actually makes a living out of selling chips, we look at all that stuff and we say, it's just software. Really? I mean, just transcode between one to the other, either on the web or on the device. And the reason I say that is actually kind of half facetious, but more importantly, the reason I say that is because if you think of a web browser, and you guys look at a web browser, you think of how many different standards that are behind that we support. We don't really think about what standards they are. I remember the time if you're a WMV, it played. If it's H.264, it didn't play. I think that interoperability is very important, and people will solve them. But the opportunity to solve them is actually an opportunity, and it's not as much an impediment. And it's important to solve them, and we will solve them. But I think what that will do is also creates a need for higher performance processors and more memory, so that you can transcode from one standard to the other, either in the end terminal or in the cloud. It doesn't really matter, but we will need to do that, and people need to come together and make sure the standards are close to each other, and that's already getting done. As you saw Greg here, he was at Qualcomm, now he's at Intel, and a lot of smart people working on that. So those problems will go away, and we will build the processors that will enable that to happen. The other question I get asked a lot of times is actually an interesting question about homes, and a great opportunity for the people in this audience. What do you need a connected air conditioner? And that's a question that gets asked a lot of times. Actually, the answer is alarmingly simple. Now, I was in China the other day, and I was meeting the CEO of one of those appliance companies, and I asked him, they're buying millions of connectivity devices from us, putting in a lot of refrigerators, and they mentioned in a few years, most of the appliances they make will be connected. For sure, 50%, if not all of them, by 2020. And the answer was actually very simple. Most people don't have central air conditioning, and when you travel to these parts of the world, you just want to turn on your air conditioner at home before you leave the office, so when you get to the house, it's the right temperature. It's actually that simple an application that's driving a huge amount of connectivity. So it starts with simple applications like that, and it's going to move on to do actually more complex things. So that's probably the other comment I'd make is, as you start developing these things, think of the simple ones first, rather than the complex ones where you'd open the door and the lights come on to the right right light and all that. Things that actually enable users to have a great experience are the ones that sell first. I want to talk about the third aspect where we see a tremendous opportunity, and this is actually in cities. You can kind of broadly think about that as infrastructure. This is actually an area where we are seeing tremendous growth in selling connected things and also having things like embedded Linux and things like connectivity moving rapidly. And some of the areas are actually like security, like water metering, like electricity grids, and a lot of work being done, which you probably may not see it every day, but the efficiency gains are tremendous. I mean, we recently at Qualcomm launched a modem that works on a pair of AA batteries, will last for 10 years in the field. Now think about putting that modem into a water junction where whenever there's water leaks, it sends a message, and you don't have to keep, right now you keep sending people to see where the water leaks are. There's tremendous amount of water that gets wasted in the infrastructure. So there's lots of gains to be had by doing things like that. Parking, another huge issue. I mean, there's still business aspects to be worked out, but it's not too hard to think about as you probably guys drive around here, either here in San Francisco or some of these cities. You could easily have the parking meter tell you which parking spot is empty. It shouldn't be that hard because you actually have Wi-Fi to a lot of those things, and you can swipe a credit card and pay. So having the connectivity for a parking spot to tell you if it's occupied or not shouldn't be that far away. And I think those kind of things will happen. So that's another huge area. Now, what are the challenges? The challenges, apart from software interoperability and stuff that we need to work on, which I'm supremely confident will get done, is actually diversity. That is actually a bigger challenge. And what I mean by that is, I'll motivate it by the smartwatch example. You actually want to have a watch on your hand that only performs like your smartphone, but the battery is probably 400 milliamp hours or less, whereas your new smartphones have a 3600 milliamp hour battery. Now how do you manage that? And now you've got people used to having connectivity all the time, and you start using modems and all these things all the time. Now you got to get to the point where the power draw and the battery draw is not as much. You want great performance like your smartphone, but you want it to be at a fraction of the cost. So the diversity of the applications and the contradicting nature of the requirements is actually where some of the challenges are. And we need to work together to make sure that we have the right software footprint and the right kind of processors and the right kind of networks to actually deliver that experience. We believe at Qualcomm that the best way to have these things to happen, and I'm not alone in my belief, all the other semiconductor companies like Intel and TI and so on, is that the best way to make this happen is to democratize the hardware, to make available great hardware to many, many people so that the best applications can come from people in this room working on those kind of things and people like people in this room working on those things. The good news is now there's a lot of hardware available, and I was listening to Linus talk about now how the next generation hardware is so much more powerful that you don't really have to optimize your application for that, and that's so true. Now things like the Snapdragon processor and things like the Intel processors are available for a fraction of a cost, and we can make those development platforms available to the audience. So you can actually start thinking of making great connected applications without having to find that perfect optimal silicon which runs out of memory, runs out of processing, and so on. Here is another interesting slide, and I think it's a very important slide because we believe now that with the availability of the hardware, with the availability of the connectivity, and with the widespread nature of the applications, here's a report we saw from Gartner that said 50% of the Internet of Things solutions will come from startups less than 3 years old, which is startling if you think about it, if you think about where the innovation is going to come from. So as you democratize hardware, as you make available more software, as you bring this performance and connectivity to everybody, the best applications will actually come from the ecosystem. So I want to talk about a couple of things before we close here, which is the concept of things becoming more intelligent. And I get asked this question a lot of times. OK, so fine, we get all this processing out there. We get this connectivity out there. What's going to happen next? I think that perception and reasoning and context awareness is actually going to be a key part of what the new devices will do. Because when you put that kind of processing at the edge and you have this always-on connection where you can reach into the cloud and have even more resources available, the devices will get smarter much, much faster than we can imagine. And there are many examples of that. There are many, many examples. People talk about autonomous cars. People talk about security systems that are smart. I think that is something that's happening really fast, and we need to be prepared for that, there's going to be a lot more context awareness. The best devices are devices that you don't really have to tell them what to do. They do the right thing most of the time. And if all of the time, that'll be even better. So that's kind of my point. I talked a little bit about that, the concept of intelligence at the edge, and the concept of how things will be a lot more capable as we move more intelligence into the endpoint. And always-on sensing, that's another area that's happening rapidly. We can have devices now. I think Alexa is one of those. The Amazon Echo is one example of a device that's always on. And when you make battery-operated devices that are always on, then the whole concept of context awareness takes a new meaning. Far-field voice and some of those things are really happening. And again, when you have some processing at the edge and you can reach into the cloud for the next part, then you get tremendous gain. I want to talk about one topic here, which is actually the challenges and opportunities for the Linux community. And again, this comes purely from somebody who doesn't do any programming in Linux, but is at the receiving end of using devices that are made by the great work done by this team, and someone who sells chips into this space. And I want to give you an example of cameras. Almost every smartphone ships with one, if not two cameras. So at 1.5 billion cameras shipped a day, a year, there's tremendous amount of technology in cameras, and now you see security cameras in watches, and so on happening. One of the things that still is a little bit hard to do is to have a standard way of interfacing to the camera in Linux, and that would be great if that problem got solved. The other aspect of it is how to make them secure. As devices get more connected, it's important to have them be solid and easy to build solid security. That's another area that I think we could use a lot of help. So I want to give you an example of this idea of conscious camera. A startup showed me the other day. Right now, if you buy a camera, security camera, put it outside your house, it tells you when things are moving, but usually it sends you notifications that are most of the time not what you want to see. You want to know if there's a stranger outside. You want to know if it's a cat or a dog or so on. And these cameras are not that smart. They just detect changes. But I've seen now technology and presentations from companies where they have so much processing running at the edge with the deep convolutional neural networks running on the processor on the camera, it can tell you it's a car or a pickup truck or a dog or the sound is of breaking glass and so on. So the intelligence of these cameras is actually quite high. And soon you'll see this concept of conscious cameras happening. And that kind of intelligence gets into all the embedded objects at the edge. It's important to have embedded Linux, which is the platform of choice for many of these applications, have more features so that they can enable those kind of things to be built easily. So that's actually my last slide. I will just say this. I think with the technology from the mobile devices, which we have kind of optimized, and I don't just mean processors. I mean displays, I mean microphones, all those things that we've kind of gotten down into a price point that's really compelling. I think we will see a lot more Linux devices and really could use a lot of help from this community to make those easy to use. Thank you.